Hi, I'm Will.
And I'm Tom.
You may recognize this event. This is Hurricane Florence, which touched down, made landfall in southern North Carolina a couple weeks ago. But this doesn't concern us right now. It's just one of many things you could use to model this experiment with. We're going back to the present now. Uh, we're going to show you how this website can relate to what we're going to do with the high altitude balloon, like what's the wind speeds at its given elevation, its height, how it's going to track.
So if we look through this website a little bit, we're at earth.nullschool.net. This is a computer simulation of climate and weather data compiled by the Global Forecasting System, National Centers for Environmental Prediction, and the U.S. National Weather Service. Now there's a lot you can do within this website. The control panel's right here. If you click the word Earth, you can zoom out, you can zoom in, you can do all that fun stuff. You can click Earth here, and you have a big control panel. It'll tell you the date, it'll tell you the data you're looking at, the scale, the sources, and the control, which Will just showed you. We went back in time and looked at Hurricane Florence. We're back to the present now. And then there's modes. These are all the different ways you can view the data. You can look at the airflow, you can look at the ocean currents and ocean waves, you can look at the chemical composition and quantities of carbon monoxide, carbon dioxide, and sulfur dioxide. We can look at the particulate matter, which is organized by size. And then we can click on space here, which displays how intense and where the auroras will show up. There's a very light band up here if you can see it. It's pretty tough to see. But for this, we're going to be focusing on air. So within the air mode, we have a number of overlay options. We have the wind speed, which is of great use to us. We have the temperature. We have the relative humidity. We have the wind power density. We have the 3-hour precipitation accumulation. The convective available potential energy. The total precipitable water. The total cloud water, the mean sea level pressure, the Misery Index, or you can choose to have no overlay.
The primary overlay we're going to be concerning ourselves with today is wind. And wind is caused by the Coriolis effect and changes in atmospheric pressure. Wind flows from a high pressure system to a low pressure system. Okay, we cut the video there quickly, but we jumped up just to show you the different atmospheric pressures. Here is a high pressure system which flows clockwise, and you're going to have a low pressure system here which flows counterclockwise, and the air is going to flow. Remember, the air is going to flow from a high pressure system to a low pressure system, and that's one of the biggest determining factors of wind.
Another feature that will be very handy to us is this height feature. It's organized by pressure, hectopascals. This is FC is on the surface. If we move up to 1,000 hectopascals, we're less than a kilometer above the surface. Not much changes in wind speed there. If we move up to 850 hectopascals, we're about 1.5 kilometers above the surface, about 5,000 feet. If we go up to 700 hectopascals, we're about 3 kilometers, 10,000 feet. Move up again to 500, you can start noticing bigger changes. We're starting to get into the jet stream a little bit. We're entering the tropopause. And we are about halfway through the atmosphere here. We're at 5.6 kilometers. If we jump up to 250, we're in the tropopause right now. Everything before this has been the troposphere. Now we're in the tropopause, which is the most energetic area. Wind speeds jump up dramatically. And then up to 70, we are entering the stratosphere now. Wind speeds die down. We're at about 18 kilometers or 60,000 feet. Our balloon, our high altitude balloon, will end up somewhere between the 70 and 10. 10 is 31 kilometers. This is about 100,000 feet, and this is the lower edge of the stratosphere.
All right, so as you may now know, we are launching a weather balloon into the atmosphere with various instruments and things like that to collect scientific data. Very similar to what the National Weather Service actually does. They actually launch those things out of. They got a place they launch them out of in Grand Forks. Theirs are filled with hydrogen because it's cheaper. Ours are filled with helium because hydrogen tends to be a little explosive. Safety risk. All right, so the wind's going to be blowing. So as you can notice that there are various at the surface, like the wind's blowing very shallowly. It's very slowly. 2 miles, it's barely blowing at all on this day. But the wind's very light, higher than air, so it will still rise. It's using helium. As you can see, the wind's blowing a little bit from the southwest and it's kind of blowing north. So our balloon's going to be blowing northward. It's going to be going northwards. But as it gets higher, obviously it's going to encounter higher winds, higher wind speeds. Now it's up to 3, even just by being a little up. Then we get to like 850 millibars off the ground. We're going to begin to see the prevailing westerly winds, and our balloon's going to end up. And then once we get to around 700, we're definitely seeing them, and our balloon's going to start blowing northwest. It's going to blow in that direction the whole time. And then when we're around 500, we're beginning to see the lower half of the jet stream, and the wind speeds are now up to like 118. And then at 250, we're at the jet stream, and winds are blowing 163. This is the fastest our balloon's going to be going. And then our balloon's going to be rising to above that. And once we get to 700, our speeds start slowing down.
Another thing we'll see as the balloon rises in altitude and the pressure decreases the higher we get, our balloon will expand and expand and expand. And once we're in between the 70 and 10 here, we'll be close to 100,000 feet. Our balloon will expand so much it will pop. And from then on, it's the parachute descending back to the ground. And of course, the wind will affect our descent, catching the parachute back down, going from lower wind speeds back through the jet stream, very high speeds, 150 plus kilometers per hour, down to around 100 kilometers per hour, and continuing down all the way to the Earth, back to the surface where the winds will hopefully be calm for us on our launch day.
Okay, so just to wrap things up, we find this website to be a really interesting tool to model wind speeds, directions, and stuff. And we thought it was, and we think this is a really useful tool to model what's going to happen to the balloon, and just gives us a general idea of what's going to happen on that day, where the jet stream is going to be located at, what the wind speeds are going to be like, and where our balloon is going to be going.
Thanks for watching. I'm Tom.
This is Will.
We hope you find the time to go check out this website. It's a lot of fun to play around with, especially going back and checking out all the storms that happen across the world, all these cyclonic systems. This was a very useful tool, and we're looking forward to the launch.